Okay, so now we are, I'm just going to demonstrate two more things that deal with lists. This is a little more specific to dictionaries. So there is something called zip in Python. There's a method that is built in that, let me demonstrate this. So let's say I have two lists and I would like these lists to be tupleized. So like I want to kind of merge them together where the first item from each list becomes one tuple. So the first tuple will be 1A. So the way we can do this is zipped equals zip, and then I can just take numbers and letters, and then we can just print out. Oops. Let's see what happens here. Okay, I will. Oops. Too much noise in the terminal. Okay. Clear. Let's go back. Oops.
Oh, do we have to record?
I am recording.
Oh, thank you. Sorry.
No worries. Okay, so it prints out a zipped object, which doesn't really help us. So if we do, if we cast it as a list, then it will give us a list of tuples. So it'll put together those two lists into a list of tuples. So why is this important? Maybe you need a list of tuples to like out of two lists, but an even better application of this is converting it into a dictionary. So, oops, the dictionary. So if I just put dict instead in front of our list of tuples, it will convert that automatically to a dictionary. So if I say dict of zipped, then I print this dictionary, we should be able to see an actual dictionary. We did not. I think I might need to actually put the zip inside of this. Let's see. Yeah, there we go. I'm not sure why this didn't work, but
It's an interesting
yeah,
question.
but if you nest them, so you can cast this object that is returned by zip into a dictionary, and it will create a dictionary where the first element is the key, and then the second element is the value.
I wonder if, I'm not sure, could line 98, did the casting of zips to list actually affect the value of the variable?
It should not have.
Okay.
But I will try. Yeah,
That's
sometimes
all I
it's
got.
weird. Yeah, sometimes it's.
Yeah, zip returns.
Oh, it did. Huh.
Iterable,
Yeah,
I think, and that might be.
yeah, no, it did. You were right.
Yeah, no, it's confusing. It's confusing keeping track of when something modifies the variable versus when it does not.
Yeah. Any questions on this? This was just mentioned by someone, and we thought that this was a very good thing to demonstrate. But yeah, you can smush two lists into a dictionary. No questions? Okay. Let's move on. I'm gonna create a new file. Oops. I'll rename it later. Okay. So when you're building an application, your code doesn't always run the way you expect it to, and you get errors. So to handle errors that might come up, you would want to put your code in what we call a try except block. So let me just try except. Okay. So under the try block, this is where you want the code that is going to run. So let's say I have two numbers, A and B, equals 3. And I want to say D equals A plus B. So this won't give us an error, or it shouldn't at least. But let's say we add another one, which is cat. And so here, B, this should be fine. And actually, okay, let's just stick with this one. So this shouldn't give any errors, but let's say if we do get an error, it will go into our except block, which we can just print, oh no, we got an error. Okay, so what if we don't get an error? And we want to do something after this code executes? Then we can put an else clause, and we can say print yay success. So if it gets to here, the code in the try block was successful, nothing needed. Finally, so in this one here, this will happen, it will execute always, regardless of whether it was an exception or a success. And here we can say print try except, I forgot to put this as a string, try except tested. Okay, so let's run this. If we run this, we get what we expected. So it added the numbers, no errors, so it didn't go into this except block. It went into this else, and then it went to the finally block. So what if I try to add, let's say this equals A plus C. So here I'm trying to add a number and, oops, that's not a plus, a number and a string. This should cause an error. So let's see what happens. So here, when it got to here, it caused an error. Oh no, we got an error. And then it went into the finally block. This is very useful for when you're doing work with like APIs, or you're working with, I mean, it's useful for a lot of things. So anytime you expect, you're not sure if your code is going to give an error or not, put it in a try except block. That way you don't get random errors. So if I didn't have this, and if I was just trying to do this out here, actually, I'll do it above. So if I was just trying to execute this without the try except, we get this. We get a random error, not a random error. They tell us what the issue is, but you get your program crashes. And when you're, running an application, you don't want your program to crash. So this is the way to prevent your program from crashing. Handle all of your errors and make sure you, make sure you put try except blocks. Any questions on this?
Yeah, I have a question. So would the try except be like primarily like used for testing your code and not necessarily like your final
No,
code?
it will be inside of your final code. This ensures that your final code does not break in random areas. So this will come useful, or this will be useful in cases where, let's say you're handling data that you're getting from somewhere, and you don't know for sure that that data is going to be there, or maybe the format is wrong or something like that. Something might happen. You would want to put it in a try except block, because if something happens, like I said, you don't want your program to crash. And this is an elegant way of figuring out your errors,
That's
pretty much.
Can I?
Yeah, please.
Yeah, that's actually a really good point about, sorry, I'm a little funny in the video, I know. We're sharing the speaker today. That, Zaina, I want to say that's a really good point about thinking about external data. We'll see it especially when we get into web apps. Like if a user inputs data in a form, you can't trust that that data is going to be good. And even if you trust that the data that they put into the form in the browser is good, when it gets sent from the browser to the server, who knows what happens to that data in transit. So on the server, you're always checking all input, especially when we're kind of writing stuff where we take input from the command line and we're learning, we don't worry about it too much. But in general, when you're writing programs, you should never trust external data unless you know that you can, or that you don't really have to worry about it, or you've talked about it with your team. And so, yeah, saying that example is spot on, because you're writing a program. Programs mostly, data is way more important than code. It ends up being like the data that we move around is what we care about. That's the information that we care about. So most of the code that you write in your career will be dealing with parsing, transforming, working with data, business logic to do stuff with data. And just in general, you guys will discover that software is kind of one big dumpster fire, for lack of a better term. The internet is kind of held together with like duct tape, and there's tons of messy, bad data out there. And, you know, if you're creating the Nordstroms.com website, you don't want the website to crash for the user if there's bad data. If you're working at a bank, you don't want the bank software to crash because of bad data. And even not with bad data, like with bank software, one part of the program might have an error because maybe another programmer made a bug, and we're talking about an application that has like 50,000 lines of code. We don't want that one problem in one part of the program to crash the whole system. And that's where error handling and try and accept blocks matter. And we won't get into it too much, but like there are different ways that programming languages handle like cascading errors kind of up through different layers of the program. Like you might have a try except block, and inside that is like a whole bunch of other functions. So you could write a function and the function throws an error, but you call that function inside a try except block and that handles it. So there are all these strategies that we don't, unfortunately, can't quite get into. But the big takeaway is that try except blocks and thinking about errors is a tool that we use to make our programs robust, and so that a problem in one area doesn't crash the whole program, which ends up being important for mission critical software and for a good user experience. You know, you don't want iTunes to crash because it tried to connect to the server, but the Wi-Fi was off or something like that. It's a bit of a different story, but sometimes when you're writing a program, you might actually like not want to handle an error if it's something serious. It depends on how companies do it. I've been at places where we kind of decided, you know what, like if the website breaks for a little bit, that's okay. What's more important is we need to know that there's a problem. We don't want the program to like handle an error silently, because the continuing behavior will then be bad. So we'll get into it later, but when you handle errors, you also have to think about, all right, if I handle my error, how does the program continue, and will it be in a good state, or will it be like you know, in the movie when like you see some like science fiction machine and it breaks and like it's trying to keep moving, but it crashes. Like, we don't want our programs to do that either. So that was a huge digression. It's something I just kind of got excited about. So thank you
No,
for
thank
letting
you.
me jump in.
Yeah.
And all this stuff, it's not immediately relevant for most of the code we're writing. Our programs are not big enough yet. However, knowing about these things so you can talk about it in technical interviews is really important. And a big part of software engineering is just being aware of all these potential issues that almost never come up, but you have to know that they exist so that when it does come up, you can handle it. So that's the other piece. It's just kind of thinking about this stuff. So it's like, it's not something that's totally unknown to you. And that's a big part of software engineering too. So yeah, I'll just pause there. Thank you again.
Thank you.
For,
Yeah.
Can I ask one more follow-up question?
Mhm.
Just so I'm clear, and I'm sorry if this is redundant, but every block is essential for the try except statement. You need the try except else and finally.
You don't need to have them all there. If you don't need any logic in here, you don't have to have it. But typically you see the try and except together. And then these are kind of extra.
Yeah, I think the accept is the only one you need.
Yeah.
And then the else and finally, like are again about logic and like, what do we want to do when an error happens? You can also have like multiple accepts and specify different kinds of errors. Python has a concept of different kinds of errors, but that's not, we don't need to worry about that now. And a lot of the time you don't need to worry about that, to be honest.
Yeah, Michael.
If you put the V equal statement above the D equal statement, will it still do the D equal statement? Or is it just going to throw an error and go out?
Yeah, it'll throw an error. So let's test it out.
That's a great question.
Yeah, there we go. So it says, oh no, we got an error, and it didn't print out anything beforehand.
Right.
And then my next question is, if it throws an error on the accept, can we fix the error so finally shows the correct?
Yeah, so Michael, those are both great questions, but I want to add something on to your point about that, like what your first question raises is like, when we're looking at programs and code, we want to think about the flow of execution. And a lot of what learning to program is about is like learning how to build up a mental model of the computer. So essentially, like what Zainab and I do when we read code, and what all of you will be doing is you know, the computer pretty much reads it line by line for the most part. We'll see some exceptions to that later, but that's fundamentally how a computer interprets and executes a program. And we'll talk about like the flow of execution. And as you said, it goes line by line by line from one to the next. And then when it hits that error, the execution stops because there's a problem and the program halts. And as you pointed out, where we put that line of code affects what code gets run. And that's a very common issue that pops up. Like, it can make a big difference in how you handle an error, like at what point it happens. And a lot of the times when you do handle an error, you have to write logic to check state of other things. And kind of going into your second question there about, well, what happens once the error occurs? So the error in the program has already happened. There's no fixing of an error in that sense. We talk about handling an error because you can't make the computer go back in time. And so once an error occurs, if we're handling it with a try except or try catch in JavaScript block, we do then have to think about what do we want to do, and what do we want our program to do? And honestly, that's going to be very just case specific. It's just going to depend on your program and what you want it to have happen. Like, for example, if you're writing a user interface, like just to use iTunes or Apple Music or a web browser as an example, like we probably don't ever want a web browser to crash. So when we're handling errors, no matter what happens, like we kind of want to keep the rest of the program running. If we say we're handling like employee payroll and we had an error, if the error was severe enough, we might say, hey, like I need to log this error so that, like, which will then, there are all these logging tools, so a programmer might get a notification about the error, and we need to halt the payroll job because something has gone wrong with dispersing this money. And that's a serious enough task and a complicated enough task where rather than try and like write a program to fix itself, we just want the program to stop and throw up a giant red flag so that some people can come and look at the problem. Yeah, so those are great questions. And all this again is kind of outside the scope of what we're doing now, but it's really good stuff to start becoming more aware of and thinking about.
You guys.
I'm also a little confused about finally. Is it always running? Like no matter what, it's always going to run. So why do we even need a finally?
This is some cases you might need it. It's kind of there in the cases that you do need it. I'm trying to think of.
Yeah, I'm trying to think of one too.
I have no idea, honestly.
Yeah. A user interface might be a good example.
Mhm.
Like, again, with like a web browser, like if an error happens, like no matter what, like the way a lot of software works is it has for input and interactivity, it has like a loop that's continuously running to accept user input. So maybe the user inputted something bad for some reason and it throws an error, but whether the input is good or bad, we need that loop to continue so the user can input more stuff, whether it's by typing or with a mouse or something like that. So sometimes it's like, whether you have an error or not, you want logic to continue. I'd have to look at the specifics of the finally statement to see exactly how it works, because it might work a little differently, but it ends up being case specific. Yeah, that's a great question also.
I think Kayla was asking, is it primarily QA testers and software testers that do this? No, this is pretty common amongst everyone. So you should get in the habit of just error checking. And yeah, this will come up later on too, when we're writing our actual web apps. Yeah, one last question and then we'll continue, Kevin.
Is it possible to nest try and accept else statements and all that, like under the accept line? Could I put another try line?
Yep.
Bet.
We should be able to. So try, I don't know, C equals, I'll just try the, n plus 4, and then, oops, except. So you saw that it was still red until I put the except clause in there. And no. Yeah, so yeah, you can nest them. Okay, cool. Okay, so this was try and accept. Just remember error handling is pretty important when you're writing your programs. Okay, so we're gonna be just demonstrating our last part today. So I want to talk a little bit about modules. So modules, packages, libraries, and frameworks. So all of these words are just words to describe code that someone has written ahead of time to make our lives as developers easier. There's no magic. It's just meant to make our developing experience easier. So we don't have to write extra code that it's like, why reinvent the wheel if you can just import it, you know? So there's a number of package managers that we will come across. For Python, there is pip. So pip will allow us to install packages for Python. So if I wanted to install a package called NumPy, which deals with a lot of, I think, statistics stuff, like just statistic data, number stuff. Oh, I think it's pip 3. Install. I might have not installed pip yet. Never mind, it isn't pip 3. Okay. That's fine.
yeah.
I already have it installed. But yeah, this is one of the package managers for Node or for JavaScript. You're gonna find npm. So if I wanted to install a package, I would put npm I or npm install and then the name of the package, whatever it is. And one of the homeworks you'll see that because there's a library that allows us to compare arrays, and it's in the exercise description too. But yeah, so we have package managers that allow you to install packages from the internet. You can also find, so there are some links in our, what is it called? In our lecture notes. Let me show you guys this one. So this is 20 like Python libraries that a lot of people use. So there's many. You can just easily write a Python library to do something and then you'll find it. So yeah, you guys can look this over. There's like NumPy, advanced math functionalities. There is Matplotlib. I've used this before. It's for like data visualization, plotting and stuff like that. SQL Alchemy database allows you to like talk to databases and stuff like that. But yeah, so pretty much it's just code that someone else wrote that you can import. So like I said before, modules, the word modules, it's simply just a Python file that has code that you can import from another program. You can also write your own modules, which we have written, and I will demonstrate here. So let's say this is just file1.py. And here I want to define two functions. One is going to be say hello. Oh, that was my JavaScript kicking in. Okay. And then I'm going to, I'm not going to return actually, I'm going to print hello. And then I'm also going to write another one called say goodbye. Let's print by. Okay, so these are my methods. This becomes my module. I have a module called file1. And the way I can use this is, let's say I have another file called file2. And from this file, I want to be able to just call these methods. So what I'm going to do is I'm going to import file1. You don't need to add the .py. It just recognizes that file1 is a module. This is just something that Python, it's a keyword that Python uses. So use it. I am just going to say file1 dot say hello. And I'm going to call it as a function, so I have to put the parentheses after. Now if I run file2, it's going to say hello. I was able to import this function from file1 into file2, and I was able to say hello with it. So another way of importing, I did show it a little bit earlier. So let's say I wanted to import file1 as a different name. So I can say import file1 as greetings. And then here I would say greetings dot say goodbye. And then if I run it, it will say goodbye, or it'll say bye. Also, another way, if I wanted to simply import say hello, I can do from file 1, import, say hello. If I wanted to also import say goodbye from it, I can just put a comma and do say goodbye. I can also give these aliases. So say hello as hello and say goodbye as bye. And the way I can call these then is what is it called? Just hello and then bye. And let's test it out. There we go. It goes into the print statements. Any questions on this?
And then to be able to pull functions from a different file, they have to be saved in the same folder, right?
Yes, unless actually, so no, not necessarily. So for files that you've written, I think you might need to specify the path. But if it's imported through pip, you should be able to access it from anywhere. So let's say I want to import something from NumPy. So you saw it was automatically here. So from NumPy, import, I actually don't know one off of the top of my head, but yeah, so you can import something from NumPy. I could just also say import NumPy as np, and then I can say np dot, and these are the methods that I can use. But yeah, but you see here, it's a pretty big library. It has a lot of methods. And if I'm not using them all, it's just a waste of space when I'm running my program. So it is better to import specific methods that I would need to use from the library. Did that answer your question?
Yeah, I was just talking about the ones that we create.
You created, let's test it out actually. I'm gonna create one in here. Actually, there is one called data types. So I can just say import data types. It will not. So I think I have to do a dot slash or
You
something.
might-
No.
I was doing a quick Google,
Mhm.
you might have to use like the sys command. There are some Python built-in commands. We might have to get the path with some Python tools.
Okay.
I threw a link in Stack Overflow. But yeah, you can use the import statement to import from files and other directories. You just need to give it the path from where the import statement is being executed to where that file that we're importing from lives. With Java, with Python, we might need to go through a couple steps to get that path, so Python can talk to the operating system and get that. I'm not sure off the top of my head either. I threw in a Stack Overflow link and we can see if we can make it work. But
Thank you.
yeah, but the short answer is you can do it. We just not might be able to type it in directly.
Awesome. Thank you. Any other questions? No? Okay. Well, this concludes our lesson for today. Our lesson is a little short. We have quite a bit of resources. Let me just.
Oh, I have one quick question.
Mhm.
So is this basically like the same as a spec file? Like the spec files that we've been using?
Yeah, so the spec files are a good example of how we were importing the functions that we wrote in a different file. So the spec file is an example of that, yeah.
Okay.
Yeah. Any other questions? Yeah, Michael.
So if we're using multiple files, do we have to import to each and every file, or do we just import to one file and it works for all the files?
So if you're using the methods in that file, you need to import it. So if I need to use something here, I have to import it here. If I import it here and I'm in my file 1, I'm not going to be able to use it. So if I say np, oh, see, it had an auto import. np, it knew that it's numpy, but which was, so you have to import it pretty much.
And just to kind of add to that, for bigger programs, what you'll see is like, there will be like, from like Java, there's a term main method. The term varies, but essentially you might have like, you will have like the very first part of your program that runs. So you might have like one file called in JavaScript, you'll see like main.js or app.js. I'm not sure what the Python convention is, but so you might have like one file where you start your program, and in that like kind of main file, you do like all the imports that you need, and then you call things from there. So that way, when you call your other code, stuff is available. Though I'm not 100% exactly how that works with modules and namespacing in Python. I'm much more familiar with JavaScript. So I'm gonna pause on the details there. But the essence of it is that once programs get bigger, there is a lot of organization that goes around of just like making life easier in terms of like importing stuff.
Thank you. Okay, I just want to go over some of the stuff that we have at the bottom of the lesson. So we have a bunch of resources. I found, so the array methods that we worked with today, like the map and filter and stuff like that, there are JavaScript equivalents. I'm not sure if you guys came across these in the pre-work, but this website has a pretty good, it's a pretty good list of this. And then you can, let's say I want to look at map. It gives you examples and stuff like that. So in here, it gives you an example of an external function. Inserting an external function, which we kind of saw earlier today. This second link actually shows you the kind of like a lambda-like way of doing it. This is called an arrow function. It's called an arrow function, right?
Yeah,
JavaScript,
arrow
yeah.
function,
Where this one is your parameter. So it takes an element from our array, and then it will map it to whatever you want to do to that element, and then it will return a new array with the new stuff. So this has like a pretty good examples on how to do these in JavaScript. This one shows JavaScript versus Python, just if you're interested. Has some pretty good stuff about runtime and the ecosystems and stuff like that. This one is a little more on Python modules and just some examples there. And then this one is just a comparison of the import syntax, the import-export syntax. Yeah, Gabo.
Just wanted to ask kind of a tangent, but during lunch, sometimes if I have time, I start working on my problems. Are we doing paired programming on the upcoming problems, or I should not be solving them already?
Yeah, we are going to be working on them with students, with like pair programming.
Yeah.
Right?
I mean,
Should
if
we?
you want to, it just
You can get it. Yeah, you can
help
start.
everybody out, I guess, but that's
Yeah.
the plan. Yeah.
Okay, I understand.
Yeah, so these resources pretty helpful. So for the assignments today, they're similar to the ones before. There's a version in JavaScript and a version in Python. We're gonna say for today, do the Python one for all of these, and if you finish all of them, then go back and do them in JavaScript. Since the first ones we did in JavaScript first and then converted it pretty much to Python. Debug def grandma is going to be in JavaScript only. This gives you an already solved completed one, and you just have to fix the bugs. It's not going to run as it is. So yeah, that's that. One thing to say about this, so if you're having trouble running it or figuring out how to run it, I won't be able to demonstrate around this actually. Let me see if
Do you want me to share my screen? And is
Sure.
there something I can do? What?
No, it's just so make sure you have the extension live server. So which one is it? It's
You know what? I think it's no, it's not live share.
I have this one. This is the one that I have installed.
What's the one below it? Oh, so this is a good moment. So it's like,
Live server preview.
yeah, when you're looking at packages, look at the number of installs.
Oh, I should install this. This is good actually. Sorry.
No, yeah, the one you have above, that one looks like
This is the one. I tested it out today.
yeah,
It
that's
worked.
what, like 26 million daily downloads, I think.
Yeah.
Yeah, that's the one we want.
So have this, it'll pop up down here where it says go live. So when you're debugging the def grandma one, or you just want to run it, be in the folder of like the folder of that exercise, and then you hit go live. Even if you're not in the folder, so this will, hold on. Oops. Why can't I move this down? I think that's annoying. Okay.
Yeah, the full screen stuff gets annoying.
Yeah. Can you guys still see my screen? It's a new, it's the browser. Yeah. Okay, cool. So yeah, this will pop up. Then you go to wherever the dead grandma directory is, if it's not already open, and it should pop up the prompt if it's done correctly. Yeah, so that's just the way you can run this. I know some people had issues the other day. And then if you want to stop it, you just hit it again and it stops the server.
Yep.
So this will run your HTML file in the browser automatically and pretty quickly.
Yeah, it's pretty amazing. It's, yeah, we haven't talked about a ton, but editors like VS Code have tons of super powerful extensions.
Yeah.
This one's starting up a tiny web server, and then it hosts basically whatever HTML page it finds within the directory that your VS Code is open to.
Yeah.
I think that's about right.
Mhm.
Yeah, and it looks like
Jim?
Hi, guys. Is there any impact to having a great number of extensions installed? Do they challenge memory, or
I
are
think
there
if the computer can handle it, it's fine. Right? I think,
Yeah.
yeah.
it can end up messing up memory. It just totally depends on your computing horsepower and what the extension is doing. Some extensions are really simple. Some, if they do a lot of code analysis, might eat up like more memory and slow the editor down. It's really just going to depend on your computer and the extensions themselves. Generally speaking, unless you're already seeing performance issues with your computer, you should be able to install some extensions. I wouldn't worry about it. You'll notice if it becomes a problem. And the nice thing is it's really easy to disable extensions in VS Code to enable and disable them.
Yeah.
Yeah.
So you can just go. So if you don't have anything here, you'll have your installed ones. And you can just click on it, uninstall, disable. Disable will just turn it off, but it's still installed, and then uninstall, obviously we'll uninstall it.
Yeah. And often there are settings and kind of like documentation here for extensions as well, which is good to see.
Yep.
Yeah, no, that's a good question. VS Code is pretty lightweight, generally speaking.
Yeah.
Yeah. Thank you.
Okay, any other questions? We are done with lecture today.